read the question carefully. In this mass spring system, our initial value problem is always like this: m u double prime plus gamma u prime plus ku equals ft, where m is the mass of the object, gamma is the damping constant, okay, k is the spring constant or coefficient, and ft is the external force. Initial displacement, u prime means initial velocity, some value. So in this question we have an object that weighs 16 pounds. So from this we can find the mass. So mass is 16 pounds, that's the weight, divided by acceleration due to gravity 32. So we get 1/2. And that stretches a spring 3 inches. So the stretched length L is 3 inches. We need to convert into feet. 3 divided by 12, 1/4 feet. From this we can always find the spring constant K. Okay, K is weight over stretched length. Weight is 16 pounds. Our weight is same as mg, mass times acceleration due to gravity. In any case, that's 16 divided by stretched length is 1/4, which then we get 64. And read the question further. The object is attached to a viscous fluid with a damping constant gamma, damping constant of 2 pound/second per feet. So 2 is the damping constant, it's given here. Now the object, if the object is set in motion, so that's the initial cases now, initial conditions. The object is set in motion from its equilibrium position. So initial displacement is 0. That's u at 0 equals 0, initial position, with a downward velocity. Downward means positive direction, so just plus, we don't have to worry about negative sign. Downward velocity of 3 inches per second. So u prime 0, initial velocity is 3 inches per second. We divide by 12, so 1/4. Now we plug in m, gamma, k here, and ft is 0, by the way. There is no mention of external forces, so ft is 0, so we don't worry about that part. And we have these initial conditions, so we set up an ordinary differential equation. Then we solve by finding characteristic equation, solving for r. Then once we have two roots, we write down the solution. So the ordinary differential equation is m, that's 1/2, m u double prime, okay, m u double prime plus k u prime plus 64 u equals 0, because this external force, there is no external forces, so that's 0. Then the characteristic equation is 1/2 r squared plus 2r plus 64 equals 0. Now we can get rid of this 1/2 at the front by just multiply this by 2. Then we get r squared plus 4r plus 128 equals 0. And use the quadratic formula here. So negative b, okay, let me just this, negative b plus minus b squared minus 4ac. A is 1 and c is 128 over 2. And we can separate into two fractions, negative 4 over 2 plus minus, and this comes out to be 4 square root of 31i over 2. So negative 2 plus minus 2 root 31i are the roots. Okay, these are complex roots, complex conjugates. So based on this, we have solution e raised to negative 2t, and from I we get cosine sine. So the solution is c1 e raised to negative 2t cosine 2 root 3t plus c2, same thing but sine. Okay, this is the solution. But look at the second initial condition. We have u prime 0. Okay, that's the initial velocity. We need to find the derivative. So to find the derivative, I want to factor e raised to 2t outside. Okay, I want to factor e raised to negative 2t outside, then remaining here. So we have a product. Okay, instead of using product rule twice, I just want to use once. So let's see, u0 is 0. Okay, initial initial displacement is 0, since this is 0, we might get one of the constants 0. So instead of finding u prime for second initial condition, let me use this. That might simplify our problem. So using u0, initial displacement is 0, we get this ut, by the way, here same thing, this is 0 when t is 0. So e raised to 0, which is 1, times inside c1 cosine 0. 0 times any number is finite number is 0, cosine 0 is 1, so just c1 plus c2 times sine 0. Sine 0 is 0, so there is no c2, just 0, so this is 1, c1 equals 0. Okay, that means our ut does not have c1, this is gone. So then thus we still need to find c2, but for now the displacement at any time t, ut, is simplified in this way. C1, because c1 is 0, so this, we don't have this anymore. C2, let me write here, c2 e raised to negative 2t and sine 2 root 31t. Now using this second initial condition, we want to find the value of c2. Okay, so using u prime at 0 equals 1/4, we get this. Okay, we haven't found the u prime t yet. Okay, so then this, so let me find the derivative here. Okay, so u prime t is equal to, we have a product, so we need to use product rule. So c2 stays there, derivative of first factor is negative 2 e raised to negative 2t, sine stays there, sine 2 root 31t, plus now derivative of sine is cosine and this comes outside, so 2 root 31, we have c2 e raised to negative 2t cosine 2 root 31t. Now we are using this second initial condition here, so u prime is 1/4 equals when t is 0, this, so sine 0, so is 0, so there is no first term, this is all 0, plus second part cosine 0 is 1, e raised to 0 is also 1, so there is 1, 2 root 31 c2. Okay, 2 root 31 c2, so that implies c2 equals, we divide 1/4 by this, means put this on the bottom, so 1/8 root 31. Okay, thus the displacement at any time t is given by this equation, and we just found c2 here, so let me write here, hence the displacement at any time t is given by 1/8 root 31, okay, e raised to negative 2t sine 2 square root of 31t. Okay, and if you go back and look at the question, we need to determine the position or the displacement at any time t. We just found that. Determine when the mass first returns to its equilibrium position. Equilibrium position means the u displacement 0. So we want to set this displacement 0 and find the value of t. By the way, sine 0 is 0, so at t equals 0, when time is 0, the equilibrium is 0. But that's not the case here. We want to find the first, when it moves and comes back to the original position. So anyway, let's set this equals 0, and that implies this equals 0, 1/8 root 31 e raised to negative 2t sine 2 root 31t equals 0. So this constant is never 0, so we can divide by this, so this is gone. And exponential functions are never 0, so this is not 0 and this is not 0. That forces this sine term, sine 2 root 31t equals 0. And we know from trigonometry that sine is 0 when this angle is 0. And then what is the next one? 180, which is pi. Okay, so this implies what I'm using here is sine theta is 0 when theta is 0 plus n pi. Okay, when where n is 0, 1, 2, 3, etc. So at 0, then pi, 2 pi, 3 pi, 4 pi, in all places sine theta is 0. But we just want to find where it comes to the equilibrium in the next round. So this equals 2 times root 3t equals first, when it comes first to the equilibrium position. So 0 not gonna work. I mean, that gives us t equals 0. Yeah, that's the beginning. So next is pi. Okay, 0, pi, 2 pi, 3 pi, etc. But when we take 0, that means t is 0. That's the initial case, and I mean that's true, but we want to find when it comes back to the equilibrium first. Okay, that's the phi. From this, t equals pi over 2 root 31 seconds. Answer. Okay, final. So we are asked to find this position at any time t and this time when it comes first to the equilibrium position. Final.